Hello everybody, welcome back to High School Tutoring. I'm your host Manny, and today we're going to be learning a little bit about finding like friction and stuff like that, different forces using mass and acceleration. So let's look at a little bit of notes, but this is really going to be talking about a lot of the times just finding acceleration at a weight and mass or continuing that way. So the formula for weight, or what you are, let's say on like the planet Earth, is mass times gravity. So whatever your mass is times the gravity. So that would just be 9.8. And so it would look more like this. So your force is equal to your mass times acceleration. This could work for horizontal, vertical, either direction. And so you can see 9.8 newtons, which is what weight is measured in physics, compared to mass, which is 1 kilogram. And that's how that works. And then when it comes to acceleration, if we had 1 newton of our net force, that would be 1 kilogram meters per second squared. So that would just make it, if it's 1 here, we'd divide that by 1, and it'd still just be meters per second squared, so this would be the same value. So we're going to be talking about how we're going to be finding different values using this, and there's going to be a couple different types of examples that we'll have later on, but we can take a look. So let's look at our first problem, or our first problem set even. So what we're looking for is we're trying to find, so we have a 100 kilogram refrigerator. So we have him pushed by a single individual. So you can see here he's pushing it with 200 newtons of force, and we want to find if there's a friction force, which friction is the physical contact force which repels against any acting force. So if we have air resistance, for example, which is kind of like a friction for non-really touching the ground, that would be kind of, if you're pushing at 200 newtons, it's pushing back at a specific rate that you're just going to have to find. So we want to find if this specific formula, like if this specific example has any friction with the guy pushing the fridge. So we know that acceleration is 2, and we want to find acceleration. And so if we look here, we can find it kind of like using this. So if we have our weight, which is 200 newtons, that is our push force, and we have our mass, which is 100 kilograms, all we need to do is do 200 divided by 100, and that should equal 2. And that aligns with our 2 meters per second, so we should be good. Yeah, there is no friction. So force of, I'm just going to do F of F, that is equal to N/A. There's not applicable, there's no friction in this problem. So let's take a look at this one again. Or we're going to take a look at the same example, just a little bit different. So again, same scenario. He's pushing at 200 newtons with a 100 kilogram fridge. And this time our acceleration is 1.5. So if we take this, what we have, we now know that 2 is not equal to 1.5 if we just shift all this here. That would mean that we have 0.5 meters. So if we do 2 minus 1.5 to represent the change in acceleration, that is equal to 0.5 meters per second squared. And that's our acceleration going against it. So now all we have to do, obviously, now we got to do what this is. So if we want to find our weight of our friction force, we want to find the weight of it. We do mass times gravity. Obviously we know, well, acceleration is the same here. So that means that we'd be doing 100 times 0.5, and that's equal to 50 newtons for our friction force. So yes, there is a friction force, and it is equal to 50 newtons. I think this would be considered you could either consider this negative since it's being pushed to the right, or something like that. So we'll just do negative 50 to represent that. And so let's look at our last one. So this one's a different example. It's not going to be using the man pushing the fridge, but we're going to be looking at this again. We're going to be looking at a new example. So a half a kilogram book is pushed along a table surface. What force of friction was exerted on the book by the table? So we have our acceleration of 2. We have a force being applied of 1.75 newtons, and we have our mass of 0.5 kilograms. So obviously we want to do the same thing we did before to find our acceleration by doing our 1.75 divided by 0.5. And so if I grab my calculator here, which this should be simple enough, I'm just going to do this now. So that's about 3.5. So our acceleration that we want is 3.5 meters per second squared. That is what we want. That is, without friction, is what we're given. So obviously we know that we're going at 2 meters per second, so we want to find the change in that. So we do 3.5 minus 2. That's going to be equal to about, that's going to be 1.5. So we're looking at that. And obviously, we just got to multiply by 0.5 now. So that would be 1.5 times 0.5. And that's equal to, I think, or just divide 1.5 by 2. And that would equal 0.75 newtons. Which means our total force that's actually being applied is 1 newton. So 1.75 minus 0.75. That is 1 newton. Or, yeah, that equals to 1. So 1 newton, something like that. It looks kind of disgusting, I'm not even gonna lie. But we're taking a look at that, and then if you want to confirm, so we have our acceleration of 2, obviously, and now that we know that we have a total of 1 newton, all we gotta do is 1 divided by 0.5, and 1 divided by 0.5 is just the same as multiplying by 2, and that equals 2 meters per second squared. So that's how we find that specific problem. So what friction force was exceeded is what it's asking. We know that it's 0.75 newtons of friction. So let's take a look at a couple extra problems. Oh god. Okay, and I'm back. So we're all good here, and let's now begin the problem. So let's begin with this right example. So a tractor pulls a loaded wagon on a level road with a constant horizontal force of 440 newtons. If the mass of the wagon is 75 kilograms and its contents is 200 kilograms and there's a frictional force of 140 newtons, what is the magnitude of the wagon's acceleration? So we're taking a look at this problem here. We have a horizontal force of what the wagon is being pulled with at 440 newtons. And we have a frictional force of 140. So let's figure that out and find our net force. So that'd be 440 minus 140, adding all forces together. And since friction is always going against, that is subtraction. And that's going to be 300 newtons F net. That's our net force. So we have that now. Now, we got to remember, we both have the mass of the wagon, which is 75 kilograms, and its contents are 200 kilograms. So we add those together, 200 plus 75, and that's equal to 275 kilograms of total weight. So now what we want to do is find the magnitude of the acceleration. Since acceleration is a vector quantity, it has a direction, but we're going to ignore that for right now. So we're going to take a look at this. Well, you obviously now, so we have this problem. We're just going to do similar to what we did here, and we're going to do 300 divided by 275, and that's going to be equal to, okay, and that's equal to about 1.1 meters per second squared. It's about 1.09. I'll just put that in like parentheses or something. 1.09, but it's very similar, and it should be just fine just like that. And yeah, that's that example. So this is a difficult example that I've seen a lot of people mess up, and I'm going to explain exactly how you want to do it. So we have our air. This is kind of like a frictional value. It's just air resistance. And then we have gravity. So we have a double chocolate chip cookie falling, and what is it? We want to find its acceleration. So we're taking a look at this now, and we have this. So we're taking a look, and we're gonna have what we want to find. Since we have a gravitational value, this is the gravity force. This is also considered to be the weight of the object. So if we think about it, we want to find the mass first so that we can find our total to find our acceleration. So if we remember here, gravity is just 9.8 meters per second squared. But that's not what this force is. This is basically saying that this force is 0.0588 is equal to the mass times 9.8. That's how we're saying it. So to find our mass, we just got to divide by 9.8. So if we do that, we divide by 9.8. And obviously, now if we just do that, so if we do 0.0588 divided by 9.8, we get that the mass of the object is about 0.006 kilograms, or if we multiply, that's just 6 grams. But we want to use it in kilograms, so we'll leave it at 0.006. Yeah. So let's continue. So now we want to find our F net, because now that we have the mass of the cookie, which is about very small, so we want to find the force, the total force that's being acted on it. So if we do 0.0588 minus 0.0188. That is equal to 0.04 newtons F net. So that's our net force. And now we just gotta find our quick acceleration. So if we have this, we have 0.006, and we have 0.04, we just put them together by dividing them. So 0.04 divided by 0.06, and that is equal to, so let's see here. So 0.04 divided by 0.006, and that's equal to about 6.7 meters per second squared. That is how we solve for that problem. So now that we have our answer, that's pretty much it. So we figured out how to find acceleration using using a gravity value. We figured out how to find acceleration using given frictional values and weight. And then we've also known how to determine if something has friction being applied to it or not, and find acceleration from that. So I hope you guys learned something a little bit. I know a lot of people were really confused, and I got a lot of questions about this when talking to other people. And yeah, I hope that's much more clear to you now, and I think that this video is pretty helpful, especially in the topic of what we're learning, applying with all of Newton's laws and different things like that. I might have skipped over a couple details, but obviously I just want to get into the main stuff. So I hope you guys enjoyed this video, and I hope you have a great rest of your day. Bye bye.